So today we're going to talk about safe streaming at scale, the practice for the safe deployment at Uber. So we provide a framework for this safe deployment. We apply that to Flink Jobs. So first, let me introduce ourselves. So first, Yao is a senior software engineer at Uber's Flink team. She is also a Apache Flink committer. She has a PhD research background. She has a lot of experience on the safe deployment for Flink Jobs. Yeah. Myself is Yusheng. I'm a staff software engineer in Uber's Flink team. I am responsible for the deployment system for the Flink Jobs, especially for large scale safe deployment. So today's agenda, we're going to talk about the Flink ecosystem at Uber first, and then we're going to talk about the safe deployment, including principles and the actions we are doing at Uber. And then we're going to talk more details about the Apache Flink safe deployment at Uber, specifically for Flink. So first, let's talk about the Apache Flink ecosystem at Uber. Before that, we talk about the Uber's business. You know that Uber has the rides business, flight business, eats business, grocery business. All the common thing in this business is that they are all real-time businesses. Yeah, so we need a high reliable and efficient real-time data processing platform. So you can imagine that as a rider, you want to get the driver's location and the notifications for them. As a driver, you also want to know all the real-time data for the rider too. Yeah. So to serve that, around the Apache Flink, we build a platform for the real-time data processing. We handle different events and handle different user cases. We handle like mobile app events, service logs, back-end events, third-party feeds, geolocations, change logs. Mostly we ingest them from Kafka, and then we also handle them using Flink as a real-time, and then send into Kafka. Mostly Kafka. We also have other thinkers. For the user cases, we can divide into three types of user cases. More real-time user cases, like real-time pricing, real-time notifications, and real-time monitoring alerts. Also, real-time user cases, like risk provisionings, market intelligence decisions, and Uber search. OLAP is also another one for the real-time, near real-time use cases. Also, we have some not so real-time, offline user cases for the machine learnings and the reportings. Of course, we are kind of move the machine learning into real-time user cases right now. To serve that, actually, we provide high availability for our platform. We are serving more than 4,500 Flink jobs in the Uber system. We running all this job for 24/7 with 4 non-availabilities. We are handling 4 training messages per day. The data freshness is in seconds, but for high-tier jobs, we actually provide better refreshness, in milliseconds level. To provide all this reliability and availabilities, we're building around with the Flink, we have a platform. The platform provides easy-to-use interface for the customers. So we actually provide 2 interfaces for the customers. One is managed Flink Circle service. Basically, the customer is more using the Circle interface, write a circle, and then they can run it. They don't have to write a code, do the compile and deploy. They still need to deploy, of course, but it's kind of like a low-code deployment. Yeah, this is suitable for data science. They can run the code in minutes. And also for advanced user cases, we allow user to write Java code. We call it FaaS as a service, a Flink-as-a-Service. So basically, we write a Java code. You can do whatever logic in using Java code, and you can do the deployment too. Yeah. With that, we actually provide a deploy system. So this is the job deploy system. With the job deploy system, all you need to do is to define a job spec, and then with that spec, we going to do the deployment for you. We can allocate the resources. Currently, we are using YAML, but we are moving to Kubernetes too, for underlying. So we can allocate resources for you. We can do the region deployment for you. Actually, we have a lot of safety features we build in here. We check in the resource allocations. We check the capacities. We check the health checks for the jobs. All the things is done here. Yeah. And another service is a watchdog service. Once you have the job deployed, we also have the watchdog watch for you. It keep watching your job if it's still running or if it is still health. Then if it's not running for some reason or it is like down for some reason, and then it's going to restart the job for you. Yeah, so it can keep this job running with low interrupt. But sometimes still incident still happens. This not only because of our services, but also the dependency services, even the infrastructure or hardwares. Yeah, for that kind of disasters, we still need to recover. So we also provide a backfill service. For the backfill service, it's combined with the ingestion pipelines we are using, because basically the ingestion pipeline is transferring the Kafka, the real-time data, into the long-term storage into HDFS, yeah, or the hoodie. And then the backfill system going to seamlessly transfer the logic from the source from Kafka going to the Hive, and then going to read the historic data. It can read the historic data like a few days ago, or a few months ago, even 1 year ago. Yeah. So you can use that to replay all the data, and then you can run the same logic for the job, and then you can still sync to the same thing, or you can sync to other things. Basically, you can replay the other things, and then you can get the data backfilled. Yeah. So that's a major part of the platform, but we also provide some support systems like metrics and alerts, securities, job metadata, and others. Yeah. So also we have different data source connectors and data sink connectors. Majorly it's still Kafka, but we also have Cassandra, HTTP, MySQL, M3. Basically it's for metrics, and gRPC. Doc-store is kind of internal MySQL clusters in Uber. Yeah. So currently we are still running on YAML, but we are moving to Kubernetes. We are in the process to re-architecture the whole system to align with Kubernetes ecosystem, including the Kubernetes operators. So that's our platform. We provide a strong support for the Flink jobs. But still, we are facing challenges. Okay, so the challenges, one of the major challenges is that the deployment. We are the engineers. We change the code. We change the configs. Yeah, so anything change, we still need a deployment. Yeah, so our customers make changes too. They change their business logic in their jobs. We are make changes at the platform levels. We also make changes to the Flink itself, basically upgrade the Flink. So all the changes are all the dependencies, all the data schema evolutions, all these kind of things could bring the compatibility issues. How we can detect them without impact the production. That's a big issue we are facing every day. Another one is the operation complexities. Basically, deploy Flink job involve different or many networks, from the infrastructures to the deploy system itself, to the checkpoint, to the storage, to the dependencies, upstream dependencies and downstream dependencies. Yeah. So we have to do a lot of operations to make sure that the deployment is success. Yeah. So that's one thing. Another thing is a major take here is that test. How we can verify all our changes safe and it's doing what it's supposed to do. Flink job is keep running like it's streaming, right? So you have to find a way to test it that make it more productionized. We can do mock test, we can do unit test, we can do integration test, but there are not real use cases. The real use cases could be very different. The data flow in different orders. It could be latencies, could be duplications. Yeah. In that case, how we can make sure our code is still running as expected? Then we need to find a way to test it. Yeah. So for all these problems, we trying to resolve, not only for Flink. Actually, at Uber, we are having a safe deployment for years. It's not only for the real-time streaming applications, that's one of them, but also for microservices and for stateful services like databases. We are implement it with the same principles. So basically, shifting left. We are doing it stage by stage, and from developers to productions, from non-customers to customers. Yeah, we want the deployment to be safe. We want to get the feedback faster, not only get the feedback in production, that's an instant, but we want to get the feedback before that without any impact to the real customers. We want it to integrate with our development pipelines. Our development pipelines have the declarations, reviews, and the CI/CDs, all the things. We want to integrate them with that too. Of course, we don't want any production impact. Hopefully, we can do that. Of course, all these operations we also want to be automatically. Yeah, so we want them to be to bring up by the speed and the efficiencies. We want all the operations to be consistent, and it can be scalable. We have so many jobs, we cannot do that one by one manually. Yeah, we want to keep the qualities and the components for the deployment. Also, we want cost savings. Yeah, with that, we actually divide this principle in more details. Like one is the incrementalities. So basically, we ramp up the deployment from one stage to another stage, slowly change it, and then affect from internal users to the customers. We want this to be detected, so we want the health check. We are doing the monitoring. We are doing altering, so we can detect any problems we have. That's essentially with one of the principles we do, and also we implement in our Flink safe deployment. Another thing is that automation, of course. Yeah, we integrate this with our automation development pipelines, so we can apply to all the jobs easily. Yeah. So with that, I think we can go to the details of the Flink safe deployment of Uber. So you're going to talk about.
All right, thanks, Yusheng. Thanks, everybody. So next, let's talk about the Flink safe deployment framework we built inside Uber. So let's look at the Flink job development lifecycle first. So on the left side, you can see without any validations or regression signal detections, the bad change can be easily rolled into staging or directly into production, right, and result in incidents. So this is a problem we need to solve. On the right side, you can see this is the current status. we have placed the multiple guardrails at different phases in the Flink job development lifecycle. And for a single deployment path, we also put several guardrails and validations on the deployment path to try to apply the shifting left rule to detect the potential issues as early as possible and auto roll back the rollout if there's anything bad could happen or already happened without a human intervention. So this can help us to reduce the risk of incidents. So we have a well-defined structured measurement for the Flink job safe deployment. The guardrails across 5-dimensional verticals. So we have deployment incrementality, we have automation, the rollback triggers, unit test coverage, end-to-end testing. On the right side, you can see there are a lot of details inside each of the verticals with corresponding scores you can get if you fulfill the requirement. And on the top side, you can see there's some like predefined safety levels, and for each level, there are some requirements on the scores in a given set of the verticals. And we're trying to use this system to quantitatively evaluate the safety, deployment safety for a Flink job. And usually, the higher score or higher level your job can achieve, that means more safety features get adopted, and we are expecting a lower risk of production incidents. So let's talk about the incidents. We look at all the incidents related to Flink in the last year, and we noticed that around 27% of the incidents are caused by bad customer job change. And on the right side, you can see most of the incident can benefit or even get avoided by adopting the features or guardrails in the 4 verticals. And the deployment automation does not directly contribute to in preventing incidents, but it can keep the job fresh. So if something bad happens, we can quickly identify which commit is bad and roll back as a quick mitigation. We have all the Flink features ready in production for customer adoption this year. And in the first half of the year, we have some early adoptions, and we have already seen around 38% of the incident reduction. So let's talk about the guardrails we have. So in the development phase, we adopt the standard industry practice on unit testing, auto execution, and coverage requirements. So all the unit tests would be auto executed for each code change, and it serves as a blocking requirement for the following, like review or landing. And also we have 2 mandatory checks. One is incremental coverage, and the other one is new line coverage. So this helps us to guarantee that there will be no regression in the overall coverage, and the new changes get well tested before merging into main. After the change get reviewed and landed, then we move to the rollout phase, right? And for the rollout, there are basically 2 sets of environments that get involved. So the non-prod ones, shown as a purple ones here, and the following prod ones shown as the blue ones here. So the rollout would be auto-triggered by CD, and it will be rolled out to the non-prod ones first, so that is mandatory, and soak for a given period of time, and then rolled into production environments. And for a given rollout, it will be conducted region by region. For example, it will route to DC first after everything's okay, and then we move further to the PHX. So this can help reduce the blast radius when something bad happens. Seeing the rollout fails and the cost drop downtime in one region, the job in the other region is still running and producing data. And for Flink jobs, there's always like debates, discussions, and trade-offs between job downtime and job freshness, right? So to deal with the different customer requirement, we provide multiple options for the production environmental rollout policy, so they can choose from. For example, if they prefer the change to be rolled into production as soon as possible when it's ready, they can choose this anytime policy. That means the commit will be immediately triggered to roll into production when it's ready. And sometimes the job, they want a less downtime, and they're not sensitive to the freshness, right? And they can choose this manual one. So that means for each production deployment, you have to manually click on a approve button. So you can only click the button when it's necessary for some critical commits that want to roll into production. And in between, we also have the time window-based rollout. For example, this example shows the production route can be conducted from Monday to Thursday, 9 a.m. to 4 p.m. This is usually the time on-call person is online. They can stand by and watch for the route. So customer can freely choose any of the policies based on their preference and use case requirement. And there are several guardrails we placed on the route phase, can be divided into pre-route and the post-route. Let's talk about the pre-route ones. So pre-route ones, basically we can apply some compliance check, and also we can try to identify potential issues that could happen during the route and solve the route to avoid like a potential unnecessary midway rollback and drop downtime, things like that. And we have the safety level compliance for some high-tiered critical jobs. So we already place a gate to require they reach a given level of safety. If they don't fulfill the requirement, their production deployment will be blocked. And this kind of a warning message will be shown on the UI for customer to either take actions to adopt a more safety feature to fulfill the requirement, or they can use break glass to conduct a emergency route if needed. We also have some resource-related guardrails, like we have the yarn capacity here. So we check the young queue resource if it's enough for the job to be launched on that queue. If it's not enough resources, and we will stop the route and show this resource not sufficient message. And also we have the young cluster back pressure detection. So back pressure is defined as the young cluster is under pressure. And for example, if there's a bunch of job requests stuck in the accepted state on young cluster, waiting for the resource to be allocated, it's highly possible this young cluster is pretty busy now. And then we will, and in this case, we will pause sending more requests to the young cluster to avoid flushing a large number of requests to the cluster when it's already under pressure. So after we pass all the pre-route validations and rolled the new commit out, and then we move to the post-route phase. So in the post-route phase, if something bad happens, we need to roll back. This is like straightforward and intuitive, right? But we don't have a native rollback support in Flink, and also the underlying computer platform Yarn. So we have to design and build this rollback action in our Flink job lifecycle management system. And there are multiple principles we consider when we define the rollback behavior. The first one, the job binary and config should be treated equally as a first-class citizen. And the second thing is that there are two main things we need to guarantee after rollback to be to the original state. One is the binary config version. The other one is the job running status. And the third one, we need to keep consistency between regions, which means after the rollback, the job binary config version should remain the same in both regions. Of course, the rollback can fail, right? So we have the abort as the failure handling for rollback, which means we will leave the job as it is, no matter what status it's currently at, and raise a warning message on the UI for the on-call person or job owner to take some manual actions to fix a potential issue. So who can trigger the rollbacks? We have several places that can detect the issue and generate rollback signals. So first one, we have the health check. This is a part of our job deployment. After we're sending the deployment request to Yarn, we will keep on polling the current running task number and compare it with the target total task number. This is to guarantee that all the task containers are up and running healthily. And during this polling, if any failure signal get, and the rollback signal will be generated to trigger rollback. And after passing the health check, we move to the alert watching phase. The alert will be continuously watched during route and also the subsequent waiting. We need waiting time because some of the alerts, they have windows, like they want to wait for 10 minutes to collect enough data to generate a signal. So similarly, when the alert gets fired, that means potentially there's something wrong, and we will generate a rollback signal that roll back this route. And after we're passing the alert chain, we still have another end-to-end testing verification. And those end-to-end testing test cases will be auto-executed at the end of rollout. And if a test case fails, then it will generate a rollback signal to roll back the rollout. So the left side shows a example that the rollout get rolled back due to some job deployment issues. The job was not healthy enough. On the right side, it shows that the job got rolled back due to the alert got fired. So for the alert, we can have alert built on different levels of metrics. For example, we can have the system metrics like from the underlying compute and networking platforms. And also we have the platform alerts that is from the provided by Flink team. And also customer, they can emit their own business metrics from the Flink job and build the rollback trigger alert based on those metrics as well. And the alerts can be scoped as global or regional. The more granular the alert is, the more accurate signal we can generate. And one thing I want to mention here is that we also have the percentage-based rollback trigger. So this is for dealing with a large-scale Flink job deployment. For example, for some deployment, we have hundreds of jobs that get deployed at the same time as a single rollout execution. And it could be pretty annoying that if only one job generates a rollback trigger signal, maybe due to some temporary issue, and it will roll back the deployment for all the 100 jobs, right? So in this case, we tend to let the rollout to continue unless there is a large number of jobs that have a rollback signal generated, like say more than 10% or 20%. Right, and otherwise we wanted the rollback to continue, and then after the rollout finishes, we will let anchor person or job owners to take some manual actions to fix the failed jobs. This example shows the job get rolled back due to the end-to-end testing execution. BEAS is the real end-to-end testing framework built inside Uber. So everything involved in the testing setup and execution are real things, like real Flink jobs, real Kafka topics, real upstreaming, downstreaming DBs and services. So this gives us the opportunity to run the test in a real-world setup and to generate meaningful signals. For Flink job end-to-end testing, we categorize them into 3 levels. The first level is the job healthiness. This is the baseline we want to guarantee, right? And then we have the job state, and then we have the data correctness check. For the baseline ones, we have provided a generic test case. The customer can onboard directly without writing a single line of code. So this can fulfill most of our customers' requirement, especially when their job logic is simple and straightforward, but we do have some complex jobs, and they need to have validations or assertions on their like job state or data correctness. So for those use cases, we encourage customer to have their own test case built and with some advanced assertions. And on the right side, you can see this is an example architecture we share to our customers for reference. So they can set up their own test cases with Flink job and Flink jobs upstreaming and downstreaming services and DBs. So as you can see, we have a bunch of guardrails built here. And how about the customer adoption journey? So actually, most of the features are auto onboarded as a platform effort. So customers don't need to take any action. They can get everything for free. But we do have some features need customer to make some choices. For example, which environment they want this feature to apply to, or which policies they want to choose from based on their own requirements and preference. So we try to make the onboard experience easy and fast-free, and the customer only need to have some simple config change, or they conduct some straightforward UI actions, and their preference would be recorded and rolled into production. So let's recap what we have today. So we have built a Flink job safe deployment framework with a 5-dimension quantitative measurement to address the core challenges in Flink safe deployment and to serve the mission-critical jobs in Uber. And the the guardrails spread from pre-route validation, policy-driven multi-stage rollouts to the post-route auto rollback. And the onboarding journey is pretty easy and fast-free. And with some early adoptions in the first half of the year, we have already seen 38% of incident reduction. And with a broader range of customer adoption in the second half of the year, this year, we're expecting this number to be higher. Yeah, thank you so much. Any questions? Yeah, please.
Is the CD platform you're using, is it like a custom Uber one?
Yes. Yeah. So we have a team building the CD support, and we're leveraging their capabilities. And also we have a collaboration with them with some like Flink specific requirements.
So you didn't build like a separate CD system for Flink, so it was kind of like shared with
Yeah, exactly.
service deployments?
Yeah, we have a team building the CD to support the whole company. Yeah, and we're collaborating with them. Yeah, please.
Do you have any guardrails on, I think you mentioned in one of the slides about the config change.
Mm-hmm.
Do you have any guardrails on the config changes as well as any load testing that is included as part of the end-to-end testing?
Good question. So the config change you're referring to the Flink job config change, right? Yeah. So exactly. So we're treating the code and config equally as a first-class citizen. So no matter they make change to the code or the config or both, they need to go through the whole process of the safe deployment, like starting from validations in the development phase and rolling to staging environment and the production environment, and everything will be exactly the same. Yeah. And for load testing, right? For load testing, that's depends on what our customer needs, right? So sometimes they wanted to verify the functionality only. They don't need to verify the load. They can register their end-to-end test at a staging environment, because usually staging environment has less load, but it can verify the functionality. Basically the same as in production, right? But sometimes customers, they do need the load testing, and they can register the end-to-end testing case to the production environment. And after the new commit get rolled into production, at the last step, we will run the end-to-end testing and to verify whatever they want to verify, like job healthiness or states or data correctness. They can do whatever they wanted to verify over there. And so that will give us opportunity to like run the test in the real world setup. Yeah, if there's no more other questions, cool. Thank you so much.